Hello and welcome everyone to our event tonight, the SPE Thailand technical meeting. My name is Pasawat and I'm from TTS. Today I'll be the host of our event. So welcome you all from everywhere. Good evening, and we will be talking about a specific topic today. So let's get to it. As usual, we've got section announcements, special announcements, and the presentation, which will be presented by our valuable guest today, and then following up with Q&A and some closing remarks. And of course, last but not least would be our lucky draw for tonight. So for those of you who have registered, your name should be in the bowl somewhere. So some section announcements. Our mission, of course, is to collect, disseminate, and exchange technical knowledge inside within the oil field. And our vision is to enable our industry to be able to be broadcasted, of course, to be shared between each other, and we learn from each other. That is our intention. Special thanks to all of the supporters. Of course, this list is from A to C. Does not mean that any one of you is important than each other, but thank you, and give a round of applause to yourself. Thank you for all the contribution. Okay, so we've got a list of SP members that are hitting 800 soon, and we do have some renewals that have already been issued. Some of us have been, of course, we need some of you guys to renew our membership. So at this point, we've got 50% that are already enrolled, and we're waiting for around 40% more. We've got some new incomers, 5% of us, 40 of them are new. So thank you. So what are the benefits of joining SPE as a membership? Of course, you've got more to learn from many people from the same industry in different fields. Of course, you will learn different topics, and you get to meet and mingle with everyone that does the same type of professional as you. And also, we've got students which are earning a lot of knowledge from the professions that have been outside of the oil field and inside the oil field. So when they come and try to learn something, please do not feel awkward or anything. Just they are mainly students trying to learn, and one day they will be part of our social business as well. And of course, everyone here mainly knows each other, and we've been together for a while. Of course, you get to meet new people as well. So that is the main key of having these events once every month for every Thursday, second Thursday of the month. We get to meet each other. So the presentation today, I'd like to welcome a general guest, which will do the introduction of the guest speaker biography. Thanudcha Khunmek. Give a hand to him, please. Thank you.
Kap. Good evening, everyone. Thank you very much. Thank you for joining. My name is Thanudcha Khunmek. I'm from PTEP. I'm also the SPE Thailand director, looking after the technical program, together with Kun Kasian and Kun Cheer. So, of course, I'm very glad to see many faces today. It seems that our speaker had a lot of fans somehow. Or they forced him to be here, I'm not sure. So, please allow me to give the speaker introduction. So, our speaker tonight is Senior Completion and Well Services Engineer at Valeura Energy in Thailand, with more than 19 years of experience in artificial lift, well completion design and operations. In his current role, he oversees all aspects of completion design, from the wellhead to completion equipment, including electrical submersible pumps or ESP. He began his professional in 2005, focusing on artificial lift and completion technique. Before joining Mubadala Petroleum in 2014, he worked as an artificial lift product line at Baker Hughes. So, ladies and gentlemen, please give a big round of applause for our speaker today, Kun Thanudcha Khunmek.
Good evening, everyone. Thank you again for Kun Panit, right, for the welcome speech. Yeah, right, like what have been done at Valeura, right, to our ESP alive. Tell you, right, how is important of the alive in try to give you an introduction of the overall picture of the artificial lift first, right? So why is it important at this stage, right? Because if you integrated the artificial lift selection, right, during the field development phase, right, you're going to plan, right? You have to plan this, right, ahead of the time, right, in order to optimize the cost that you are going to spend in the future, right? Imagine, right, if you are using the gas lift, you have to convert into the ESP in the future. Can be costly. Okay. So at Valeura, we select the ESP as the artificial lift because at the initial phase, right, of the field development, we don't have sufficient gas to do a gas lift. We cannot fit other types of the artificial lift system. So currently, right, at our field, right, all the operating for field, we operate about 150 plus population of the ESP wells. So let's give an introduction, right, of the what is the ESP. ESP can be separated into two parts, right? Okay, on the top side, right, you can see the VSD or the variable speed drive. At the downhole part, right, can be pump, gas separator, seal, motor, downhole sensor, and ESP cable. Let's go one by one. Okay, first of all, right, so it's a pump. Pump, right, the most important part of the pump is the pump stage. So the pump stage comprises of two parts, right? One is the diffuser, which is the stationary part, and the impeller, which is a moving part, right, to moving the fluid from downhole to the surface. You can see the yellow, right, half circle there. They call the thrust washer. That is to protect the wear inside the pump stage. Next, if the well has the gas, right, the gas separator can be the equipment that helping to improve the performance of the pump, right? By separating the gas, right, you can see that the small inducer here, right, from the big bubble, right, they induce the small gas, right, from the gas bubble into the small gas, right, and then this part, right, will use the gravity, right, to separate the gas out of to the annulus. So if your well have the gas issue, right, so I would recommend to use the gas separator. Okay. So next one is the seal. What is the function of the seal? Right. Seal is used to protect the motor, which is the electrical part, right? The whole of the equipment that I talked about just now is the mechanical part. So the function of the seal is not only protect the motor, it's also balance the fluid, wellbore fluid, and the internal fluid, right? Like a motor oil. Mm-hmm. So next is the motor. Motor is an electrical part, like energized by the power cable from the top. So motor is driving the shaft from the whole system in order to give the power to the ESP. And next, right, is the downhole sensor. So the function of the downhole sensor is to monitor the reservoir parameter such as pressure, temperature, or even gives the vibration of the system. So another important part is the cable. Cable can be varied into any shape, right? Round, flat, right? And then depending on the power rating that we need to use, it can be 3K, 4K, both, and can be rated, right, based on the temperature of the well. So these are the all main components that we normally use in the ESP. And each of them, right, have an important part, right, to improve the land life or extend the land life of the well. Okay, again, right. why the ESP is important, right? Life is important because in our operating field at Valeura, we use 100% of ESP in our production well, right? So if one well fail, right, can be cost of the workover from maybe 10 to $1 to $10 million, maybe depending on the environment, right? Offshore, onshore, the cost can be vary. So if the well down, of course, right, we need to work over. So during waiting for the workover unit, right, to come for the pump chain out, be maybe 60 days, 90 days, or even longer. So at that idle period, right, so you're going to have the deferred production, right? If you're counting like maybe 100 barrels a day, right, of oil, right, multiplied by oil price now, maybe $60, and idle period maybe 100 days, right? So you can calculate, right, what you are losing during these idle times. Yeah, let's talk about some statistic, right? So normally we can use these three main statistics to measure your life, right? So the first one is the most easiest form of the artificial lift, average life. So we use just a normal statistic, like just the summation of the ESP life divided by number of the ESP. So, but this one is not really completed, like represent the performance of the life, right? Because it's taking into account of the only the running equipment in the field. So the other form that we normally use is we call the mean time between failure. So this one is represent better in terms of the statistic because it's counting of the failing and the running equipments at the same time. So, and the last one, right? If you have frequency of the failure, right? We tell you, right, how often that your equipment is failed, right? This is another form that they normally use in the to measure the life or the performance of the ESP. So anyone can guess what is the good average life of the ESP? Anyone? 2 years? 4 years? Yeah. Okay. Actually, right, there is no right or wrong number. Like if we're talking about only the average life. So whatever number that you said, like if the well is economics, right, for that specific life, can be a good life. But next question, what is the industrial standard for the ESP life? Anyone can guess? Bigger huge? You can't say you don't know. Okay. So normally, like based on a lot of like SPE papers, right, they refer to about 1,095 days, or about 3 years. So this is a rule of thumb that we normally use in the ESP industry. Okay. So these are some factors that we have an influence, right, to the life. So can be well temperature, viscosity, right? If we're talking about the well conditions, or equipment design, right? That can be affect to the life. Imagine, right? If you put the wrong pump, such as like you put the low volume pump, right, without the gas handling device, right, in the high gas production well, right, that can be affect to the life of the equipment. This is part of it. And manufacturing standard, that is one of the things, right, that we should tackle from the day one. If you starting the contract, this is, should have an important role in the contract, right? And of course, right, for the quality of the field service, that is another factor to me, right, I used to work as a field service before. So a good quality of the field service standards, right, it impact a lot in terms of the ESP run life. And next, right, so talking about the knowledge. Back to our day, right, when we have a poor run life, we found that, right, our people also lacking of the knowledge about it. What is the ESP? How is operating, right, and how can make it better in order to achieve a good life. So, and the last one is about the failure analysis. So what should I say here is that if you have the failure, if you haven't investigated what is the root cause of failure, you can have the repetitive failure again, right? So before you select the new equipment, right, to work over your well, you should find the root cause first before you go to do a workover. So I will have some example, right, based on all these factors. So let's say this is one example of our field, right, with the average run life. So this is the area that we focus at that time, say about 2014, right, that we have, let's say, poor run life, because average run life is only about 900 days, right, MTBF about 930, right, and look at the frequency of failure, 30%, right. So next one is, this is the standard that I'm talking about, 1,095 days, right, about here. Okay. So today, right, I'm going to present, right, how can we improve from this point around this area up to here. So this is our current run life. About average is about 1,900 days, right, with the MTBF of the 4,000 plus, and look at the frequency failure, right, only like 4%. So let's start with what we have been done, right? So we use this, we call the life cycle of the ESP. First of all, we start with the design and specification. So back to what I just described, right, about the select the long pump, right, with the long well. So what we have been done here, right, we start grouping the flow rate. You can see that we have like group as a high flow, medium flow, and the low flow rate here. And not only the flow rate, right? We look at to the total dynamic head of the pump, right, in order to size pump stage properly. So we group this, right, and then standardize the equipments across the field. Because in the past, we used to have like 5 well with 5 pump model, or 10 well with 11 model, right? So we are grouping 3 model. Okay, so next, right? For the well that we have a gas interference issue, okay, we also integrated the gas handling device into the design to prevent the gas lock. So to explain the gas lock, right, you can look at this picture. Right, you can see that normally, right, that because of the fluid gravity, right, the lighter fluid, right, tend to be accumulated at the center or the eye of the pump stage, right, and the heavier fluid, which is maybe gas or oil, will be accumulated outside. So this is the equipment that you see the hole at the middle there that are helping to flow the gas at the center. But of course, this one will trade off with the lower head of the pump. Another thing that I forget, this one, okay. So not only for the correct sizing, we also, right, at the sizing, we look at the operating range. So we will design the operating points of the pump into this area, which is we call the best efficiency point or the ROR, the recommended operating range. So we not sight the pump right into this up thrust or down thrust. And unfortunately, like today, I cannot talk about the design too much, right? Because that is not the objective of my presentation today. And next, right, what we have been done, right? If you look at the picture on the left, right, that is we call the back system for the seal. On the right, we call the labyrinth system. So in the high inclination well, imagine, right, maybe 80 degree, 90 degrees, right? And if you use the labyrinth, right, you can see that it can compromise the chamber capacity, right? That, right? So instead of using the labyrinth, we change the design to use the back system, right, with our high inclination well. And the last one is about we design the metallurgy, right, for the maybe corrosive or the sandy system, like we use and we call the AR, abrasive resistant, right, integrated into the pump. Look at the well temperature again, select the elastomer that properly for the well temperature. That is about the design. This is some example, like that the technology that we are implemented, right, in order to improve the operating range. Look at this green area here. This is the previous pump model that we selected, right? So sometimes we don't know some of our wells the condition can be uncertainty. So we don't know yet, right, what is the lowest point of the production, maybe lower than 4,000, right? So we select this called the extended range pump, right? In order to extend the operating range, right, on the left side, a little bit more, about 2,000, about almost 2,000 barrels. So that is to accommodate the down thrust of the pump. Okay, this is another one that we are used, right? So with the slot constraint and our platform, right, location, some of the well, right, we need to do, we call the shallow kickoff in order to hit the target. So, and our well design normally, right, the limitation of the ESP is about 6 degrees DLS, right, or dock leg severity, right? But some of our can be exceed 6 degrees, right? So we cannot find a solution until we found this technology in the market, right? That we use this one in the well that have DLS more than 6 degrees, can be up to 15 degrees, in order to unlock some of the well that we have very short life because of the equipment breakdown at the connection. So what is the technology, right? The technology remove we call the bolt connection between each system, between each component, sorry. Between pump, motor, seal, like used to be the bolt connection. So this one is a thread connection in order to providing more flexibilities of the equipment when passed through those high dock leg. Okay, so but before we start to install the equipment, right, or place an order, right, we need to check all of this. For example, like sizing, you need to question yourself, does this pump meet the flow and the head requirement of this well? Or on the operating lane, which is the pump, is it operating in the operating range, or whatever condition, right, that they're facing in the future, like maybe the flow maybe not high as your expectation, or the flow may be lower than what your expectation. So that extended range, right, can be helped in this case. So, and again, right, for the environment, right, these are the 3 keywords, right? Sizing, operating, and envelope. Sorry, sizing, envelope, and the environment. These are the 3 keywords, right, when we check the design. But the same, this is just an example, the same thing, right, will be applied to the palm mortar seals again. Because, for example, that I give, right, like the seal, right, if you have the high angle well, you shouldn't use the labyrinth seal, you should use the back. So I already finished the design and the specifications, right? So next is the manufacturing and installation. Okay. The way that I will explain this one, right? I used to heard about the joke before. It's about, anyone know what is the difference, right, between the complete and finish? Okay. Okay. Complete, like, they said, if you can find the right woman, that is your life will be complete. And again, like, if you find the woman, right, your life finished. So select the right partner, right, the right business partner, right, is the key of the success, right? So what we actually do in our organization, right, before we start the contract, we perform the workshop, right? Call the potential contractors, right, in the market, right? Perform the workshop and see their capabilities, right? What we can do, what they can do, and what kind of service or product that they have, right? So we can pick and choose, like, which one is fit to our field, our well, right? That is part of the pre-qualification. So again, right, in the manufacturing, right, you need to put it in the scope of work clearly, right? What kind of the API standard, right? What kind of equipment that you need that fit into your well. You providing the well data. Some of you, right, maybe not sure about the well data, you can give it at a range, right? Pressure, temperature, right? In order to size it properly. And of course, right, if the ESP is so important, right, with your fields. So why don't you set the target as the goal for your business partner? You can see on the bottom, right, that we put the target life here, right? And then whenever they pass this target life, right, you can give them some incentive, right, as the attractive bonus for them, right, in order to perform the job properly, whatever, like equipment, design, preparation, installation, right, even the monitoring, they should be part of this work with you. And of course, right, another idea that we have, right, we can open the competition, right, to any business partner that willing to help you, right, to improve the life. You don't need to have only one contractor, and have two, right, for the competition. Yeah. For the installation, this is just an example that we use, right, in the workshop, right? We call the pre-delivery equipment, like, inspection. Instead of, like, sending the equipment straight to the field before the installation, so we do some checking, right, in order to confirm it's in the good condition, right? No supplies, we put in the box, we send out, right? And it's ready for the installation. So the side benefit of this, right, also helping you, right, to reduce the working out at the rig. This is a side benefit. So next one, the startup and operations. Yeah. I already touched on the knowledge sharing, again, but I can say it again, like, in the offshore, right, we can train our people to understand more about the ESP components, right, and then how it's important, right, of the run life. Can share this knowledge, right? So, for example, what are the parameters that they need to look, right, or monitor in offshore? For example, like electrical part can be the amps, the voltage, right, or even the pressure. That is another parameter that they can monitor. Mhm. But in our field, right, we integrated we call the SCADA into the monitoring system. Like we are customize the parameter such as discharge of pump intake, temperature, vibration into our monitoring system or the data historian, right, to monitor the ESP, right? And not only that, right, we are also monitoring the operating condition, right, whether it's in the upthrust, downthrust, or it's in the recommended operating range. You can see that the number of our well, right, can be up to like 99.5%, right, of the within the ROR. That is very important, right? And not only on the performance, right? Another thing that we should look, right, is the power consumption, because that where you spend the money, right, to top up your diesel generator offshore, right, to power up the ESP. So you can see this graph, right? We are plotting between the liquid rate, right, and the power consumption in kilowatt. You can see that the group, right, these are in the group or in the baseline of the power that you input to the well and the barrel that you get out in the right here in the average. But some of the well, right, that show you, right, that you are out of the range here, that the well that you should focus on the power consumption or what it can cost you. It costs you, right, more power to produce the same amount of the liquid. Okay, all the ESP optimization that I talked just now, right, can be performed by the people, right? But either on your side, like your operation team, your production teams, or even by your business partner. But it's a time consuming. Imagine, right, in our field have 150 wells, and we need to monitor all these wells every day. It takes time and labor, right, to do it. So it's an AI world now, right? You know, the chat GPTs, Copilot, right? That is an AI, right? So one of our colleagues here using the AI base, right, to monitor the system instead of using the manpower. He trained the AI, right, by inputting all the well data, production data, and the ESP data into the AI, and the AI start learning the process, right, and he also putting in the real-time data into the AI, right. All this data, right, we need to process into the AI language, so that take time, right, to AI to understand all this data before it is implemented. And not only all this data, okay, he also including the nodal analysis, right, of the pump, so to see that the performance of the pump, right, into the model. So if the AI detected like gas lock, they can notify the operators or the production teams, like, to adjust the parameter to prevent the early life failure of the equipment. Or some of them can be solid like sand, right, can be detected by this AI, right? So if you want to know more about this technology, so, you can scan this barcode, right? It's the SPE paper published. Okay, I will group this into one or two slides, right? So next is about pooling, tear downs, and analysis, right? And design or procedure modification. So again, right, this one, AI helped me to do it, right? So we call this, we used to have the multiple failure with the same occasion, right? And we never, at that time, at that point of time, right, we never analyze or find the root cause. And we keeping failure and failure again. So if you want to prevent the future failure, like, so you need to conduct an like comprehensive analysis, right, before you go to the next one. So the field that I'm talking just now, like these are the example of the failure that we have, right? Electrical grounded, mechanical stuck, right, at the pump, the seal failure, right? I already give you an example, or even the installation or error. So this is the picture, right, back to 2014, 2013. So you can see this from the different well, or even some of them in the same well have the repetitive failure at the porthead of the motor. And at that point of time, there is no finding of what is cause of this failure. So we are keeping installing the equipments. So from that, from the previous picture, right? So these are the improving, right? So we are changing the new, that part we call the MLC or MLE, model leads extension. So we are adding the lead cable sheet, right, into the MLE and changing the, instead of the, we call the tape-in type, right, which is old technology. With the new one, we call the plug-in type. You can see like which one is more preferable, more preferred in terms of using, like this is just like you plug in your television at home. And this is just another example of the improving the equipment liabilities. You can see that on the top side there, that is a back rupture or the back failure when we pull out the equipment and tear down, right? So what we found here, right, first thing is about the temperature of that well. It's higher than what we expect, right? Another thing is about the pressure that acting on the back, right? So what we implement here, right, we are applying called the back protection cap, right, on the top of the seal. And we also changing the material, the elastomer material of this seal, right? And so the next workover, we pull the equipment and we tear down the seal, right, to see what is this the improvement, right? You can see that the seal is look brand new, right, from the pooling, right? And the cap is there, right? The back haven't rupture like a previous installation. So I already complete this cycle. So in order to keep improving your life, right, you need to have this continuous process, right, in the organization. So these are some of the key takeaway, right, for today, right? So if you want to have a good life, set it as your corporate KPI. That help all the department, right, that involved in this, like subsurface team, production teams, right, will help each other, right, in order to improve the life and meet the target. Another thing is, again, right, about complete and finish. if you select the right partner, right, that will be helping you a lot in terms of the improving your ESP life. Then, like installation, operating, this is part of the cycle that I'm talking about. And the failure analysis, that is also a key important role in that cycle, right? And that bullet about the no silver bullet is like different field, different operator, we have a different issues. So what I'm talking about today, right? Maybe part of it can be implement in your field, or you're facing more issue that maybe need to find a new solution. So, and again, the improvement is a team effort, right, for all the department that we have in the organization. So finally, I would like to thank you, the Valeura management, for all the support that we have to improve this ESP life from day one, right, in the poor life, right, to above the average life. And I would like to thank you, the development team and production team members, who working together, right, coordinating and helping each other, right, to improve their life. And of course, I would like to thank you all the colleagues and the business partner who working together. Okay, I think that's all.
Thank you very much, Kun Thanudcha. As you all may know, this is the Q&A session. Please stay here first. So any of you guys have any questions related to ESPs and how to preserve the life of this technology, please feel free to share your thoughts or ask a question. We've got Kun Panit also walking to the back of the room.
Yeah. Any question? All clear? All good? Time for drink? Or?
I do have one question myself, but I save it for the others.
Okay,
first.
sure. Okay, sure. Thanks, man.
So I have, please go ahead.
Didn't mean to upstage you. I apologize. Frank Timmons, Tractus. Simple question. When I was a young engineer, process engineer, we didn't have AI or all these neat tools. My curiosity, sometimes we have a calibration drift or sensor failure. Are these AI systems able to recognize problems that are perhaps not a problem with the pump or the installation, but actually problems with the quality of the data that's being received?
Okay, beside the sensor data, right, that giving you the intake pressure, temperature, right, we can, the AI, right, I understand that they can learn other parameter also in order to detect the problem. Am I answer your questions? Okay.
Okay. Any
Okay.
other questions,
Okay,
gentlemen
sure.
at the backside?
One question. I'm a surface facility guy, so it might sound a bit of a stupid question. Is there any rule of thumb where you would see the like dual ESP vision? And does Valeura has any? Because with the workover cost high,
Yeah.
as a surface facility guys, I would say dual ESPs everywhere.
Okay, dual ESP used to be one of the, I say, completion configuration that we used to consider. But again, right, on the field development phase, right, you need to think about your well construction. If your well construction maybe 958, right, casing, it can accommodate to ESP in the well, right? But there was some complication also in that case, right? You need maybe to what you call the penetrator at the wellhead, right? In order to accommodate to ESP in the well, right? And you need to think about the power consumption at the surface also.
Any other questions? Okay, I do have one. So as a wireline guy, I don't have much experience on ESP. What are the considerations for a well to have an ESP, and is the pro of having ESP? Because from what I understand is you kind of limit all the workover that you can do after that, right?
Yeah, it's not really limited workover. Um, First of all, like the benefit of ESP, of course, like it can lower the bottom hole pressure, right? Comparing to other form of the lift, like for example, cat lift, right? That is the benefit. And so if you can lower the bottom hole pressure, get more oil recovery. Mhm. That's his answer, right? And talking about the workover, right? There was the system, right, that they call the wildlife ESP, mhm, that can helping in terms of the workover limitation. For example, like the platform that you cannot lift up the workover due to the weight of the workover itself, right? You can consider that system.
Thank you.
Please allow me to save the best for last. Um, where are the students? Raise your hand, please. Only 2 of you? Oh, you must be lucky today. Any question? Great. Thank you.
Hello, my name is Shabin Wong from the Geology, Chulalongkorn University, and I'm curious that the ESP pump, is there a specific of the pressure and temperature? If there any change in the future of this parameter, what should we do or can make some way to it? Thank you.
Okay. Of course, right. Like I explained, right, in my slides, right. Is there any change in the future, right? When you pull the ESP, right, and you tear down, that is the evidence, right, of the next installation for you, right? You can change, like I said, like we change the elastomer. Mhm. We improving on the cap, right? Put the cap to prevent the pressure. Mhm. That that's the only way, right, that you can help to improve the run life. Maybe the first pump, maybe the sacrifice pump. Mhm. The second one, right, maybe run for another 10 years. Who knows?
Thank you.
Any more question?
I have like a question because working work over. I heard that you said earlier is that your ESP have years and that lifetime, right? So if the work over reason is just like a tubing leaks and I pull out your ESP and I run back without like any investigations because like the previous one is in the good condition.
Okay, very good questions, actually. This one. How can I answer this, right, without the commercial related? Okay, okay, let's say like this, right? If your well work over cost, right, is certain number, like X dollars, right? And it's worth to rerun the equipment, you can do it. But in our operation, it's an offshore operation, right? There are certain number, it's quite a high value for the workover. So in our operation, prefer to run a new set of the equipments.
Uh, like a curious, the cost of investigations a little bit higher, like almost like first buying the yeah, just
Yeah.
thank you.
Yeah.
Any last question? No question from ESP provider? I just ask, I don't know. Doesn't matter. All right. If no, 3, 2, 1. So that's it. Thank you.
Thank you very much, Kun. So we would like to welcome, as a token of appreciation, Kun Anupong Chailet, SPE Thailand Secretary, to give to our guest speaker today of honor. Thank you คุณธนัชชามากๆครับ So as a closing remark, of today, we'd like to thank you, and also there's a lucky draw. Before that, we'd like to give out some announcements for the next SPE. These are the events that are upcoming in our region. Of course, this is not just limited to Thailand. I myself will be in one of those during 19th and 20th of August. That is in, of course, Jakarta. So feel free to attend one of these workshops. They are really useful. They are really knowledgeable, and you will meet a lot of people that share the same interests as you guys. So I highly recommend that. Also, so don't forget to register for ASEAN Geoscience, of course, for students. And we have a lot of home pages, including Facebook, LinkedIn, and also Line Official. Feel free to get newsletters and also any announcement that I made real time through these platforms. And last but not least, the lucky draw. Kun Thanacha, would you mind picking one lucky draw only or two? Two. Okay, this time we have two. So sorry, Kap.
Today we got the mouse pad. Not sure if you know what it is. You can sleep on it as well, I think. It's a huge mouse pad.
Okay, so actually is this from one of the universities then? John Stoll, Chulalongkorn University?
Ooh.
Okay.
Oh, congratulations.
Are you a student?
Can we check your ID?
Everybody's still learning, including me, so sorry about that. Also, Mr. Leonard Miller from Chulalongkorn University. Another student.
All right.
Got two students today.
The only student in the board?
You're studying life, right?
Congratulations.
Once again, applause to Kun Thanacha for today's presentation. Closing out, we'd like to thank all the sponsors again for SPE, and thank you for your kind support every year. 2 for 1. Ah, okay. Don't forget, Rendezvous has 2 for 1. You get 2 drinks, you get to only pay for 1, so that's how it works.
The secret code is SPE. So
SPE.
please enjoy.
Enjoy, Kap. So that is it for today. We'd like to thank you all for attending this event, and feel free to catch up with all of us again in the next coming month. So thank you for your kind attention, and give a round of applause to everyone today, Kap. Thank you. Have a great evening.